I want you to imagine a parking lot where cars are parked everywhere. There is no system to parking. And imagine you trying to find your car. What a headache. I can guarantee you, even thinking about it, it gives me a headache. And that is exactly how programming can feel like if you're not using OOP, which is object-oriented programming. Okay, so in the next 7 minutes, let's discover how OOP, object-oriented programming, can take all this chaos and turn it into a well-organized and efficient system. Coming right up. So if you've been programming for a while or just starting programming, you may have heard of OOP. I like saying OOP. OOP, which stands for Object-Oriented Programming. Now, what is OOP? OOP is a programming paradigm that essentially structures the way software is built to mirror the way the world works, the way we treat objects in the real world. So just like a car in the parking lot, objects in programming do have what we call attributes. So in this case, we talk about properties. It could be the color of the car, make, and so forth, as well as behaviors like starting or stopping the car. Imagine you are managing a fleet of cars in a rental company. Using a non-OOP approach, meaning you use the procedural approach of creating this software, you might go ahead and separate every single thing that you want to do in your system using functions. So for each action, like renting a car or servicing it, you would have different functions that do that. Now, this might be great when you have very small numbers of cars because you can manage that. But things change when you have a large amount of cars and different needs for each one of those cars. Now, the better way is transition into OOP paradigm, because now what you will have, we're going to be able to encapsulate every car details into a single car class. So class essentially is a blueprint that is then used to create an actual object. This means now each car can manage its own state because each car is its own entity. And the way each car manages state is through the methods of that class or object, which makes our code organized and cleaner. And there are 4 main pillars when it comes to object-oriented programming. They are encapsulation, abstraction, inheritance, and polymorphism. Let's go through them in our example. When we talk about class and objects, we need to talk about encapsulation, because the idea of having a class or an object is that we're encapsulating all of the things that a class needs, an object needs to operate on its own. So essentially, it's like giving each car in our lot a lockbox, meaning nobody else can come in unless they are authorized, which also means only authorized methods inside that car are allowed to change the state of that car. And this is a very important concept in OOP, because now we only allow internal state to be changed internally with authorization, which will safeguard against accidental misuse and errors. Now, the beauty of object-oriented programming is that we also have to enforce abstraction. What that means? Well, it means that we simplify how we interact with these cars. In this case, you don't need to know how the engine, how the brake system, how the wipers really work in order for you to be able to use a car. And so that is the beauty of object-oriented programming, is that we create these entities that once they're created, we can just use them and we don't need to know about the internals of how they really work. We just know how to access it and use it to communicate with other objects that need communicating with. A car is a car. You don't think about the engine when you want to drive a car. Go ahead and start ignition and then you keep going. So the same thing happens with programs. The idea is that we have an object that we can use through methods, say start car or stop car and so forth. And that's how abstraction works, and that's why it's so important. The third pillar of OOP is inheritance. Now, this is one of my favorites because this is where we see the power of object-oriented programming. Inheritance, what is that? Well, inheritance lets us build on existing classes, because the idea now is that we already have a base car class. For example, imagine that we want to create a different type of car, but that has the same base functionalities, same base attributes and methods of the general car. So imagine that we want to create another kind of car, electrical car. So instead of starting from scratch, we inherit from car, and we can add unique features like battery management and so forth to the electrical car. Now the power here is that we're leveraging what's already done. We have already car with all the properties and methods. Now we're using inheritance to create other different kinds of cars which will have the same properties as a car, general car. Now we can add our own properties as well as methods. And the fourth pillar is polymorphism. Poly is from Greek, which means many, and morph also from Greek, which means form. So polymorphism means many shapes. So the idea here is that it lets different classes respond to the same method call in their own way. For example, both car and electrical car have a start method, but electrical car might check its battery before it does anything. So with OOP, managing software projects becomes much easier and well organized, just like having a well organized parking lot, because now each car has its own spot and its own rules that it has to abide by. And the beauty here, because it's a system, we want to make sure that everything is compartmentalized, but everything works together. So now adding, for instance, a new type of car or changing how a car starts will only impact that specific type and not the entire fleet of cars. Now think of it like managing a team. Each team member or object has roles and responsibilities. So in this case, these are attributes and behaviors or methods. Just as a manager delegates tasks based on those roles, our programs calls methods on objects, making management streamlined and scalable. All right, and that's a wrap on OOP, object-oriented programming paradigms. And I hope I made time how to turn a very disorganized parking lot, as an analogy, into a very organized and scalable, efficient parking lot. From encapsulation to polymorphism to inheritance and abstraction, these pillars are very important into building software that is scalable, secure, and manageable. And time.